Today we're going to analyze logarithmic functions. That means we're going to do the transformations of the graphs. So, remember these A, B, H's, and K's? Yeah. So what does A do? Vertical stretch. What does the B do? Horizontal stretch. What does the H do? Right or left? Up or down. Okay, so look at the following example. Describe what happened to that base logarithm. And of course, this C, again, is the base. It's not a transformation, so don't think that that is something there. Okay, who would like to tell me the first thing that happened here? Okay, yeah. Vertically stretch factor, what? 1/4, yeah, you have to say what it is. Okay, and next one. Very good. Yeah, it's a stretch factor 1/3. Some of you forgot that yesterday, so make sure you remember that the horizontal stretch is the reciprocal factor. Okay, then 2 left and 7 down. Yeah? 7 units down is even better. There you go. Okay, moving on. We're going to graph the base, then we're going to graph the transformation. Before we graph the transformation, can anybody tell me what happened to this transformation as compared to the base log graph? It went 1 right. 1 right. Does everybody see that would be 1 right? Okay, so until you get really used to the log graphs, this chart, the way it's written, might be too hard for you to fill out. So sometimes I would suggest changing the log into the equivalent exponential form until you get your brain switched. So who can tell me what the equivalent log form is for y equals log of x base 3? 3 to the power of y equals x. Okay, so then that's sometimes easier to do. Notice that you will not be choosing your x's, you'll be choosing your y's to get your x, right? So for instance, when y is 0, that's how I get x is 1. So let's do when y is 1 this time. What is it going to be? 3. Does everybody see that? And if you want to, you can do 2, but you might want to do -1 because I think it's just too... it might be too big. So when y is -1, what's my x? 1/3. Okay. So let's plot that. Again, we have to label our x and y axis. 1, 2, 3, 1, 2, 3. And I'm going to put a scale just so that I don't lose any error marks. So I'm going to plot 1, 0, 3, 1, and 1/3 -1. So it looks like that. Yes? Okay, so the transformation is 1 to the right. So I'm going to switch colors here. So I'm just going to move those 3 points right 1. So now I'm going to be at 4. I'm going to be at 2, and I'm going to be at, I guess, 1 1/3, right? So now where's my new asymptote? Huh? Negative, yeah, it's at -1. So watch when you do that so that you, +1. Yeah, +1. Okay, so that means it's x equals +1, yes? My vertical asymptote, I'm stating twice, I don't know why, but let's do it again. My new x-intercept would be, what? 2. My domain? My domain? No, it's not 0. Yeah, 1 to infinity. And my range? All reals, so -∞ to infinity. Yes? Okay, so what is my base this time? It's 10, yeah. So remember when we switched this to the equivalent exponential form? So it would be 10 to the power y equals x. So when when y is 0, x is 1. So when y is 1, x is 10. You don't need to fill out a chart if you know where it's going to go. After you do a few of these, you'll just know what the base graphs looks like. When y is -1, you get 1/10, right? So again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. X, y. Can anybody tell me what this transformation of log x plus 2 would do? Does everybody say it would go up 2? Yes? Okay, so again, it's going through 1, 0. Then it's going to be 10, 1, and 1/10, -1. Don't forget your asymptote. Where's my new asymptote? It's the same. Yeah, it's the same. Does everybody see it's the same? If I'm going up, that's not going to affect a vertical asymptote, right? Only an x would affect the vertical asymptote. So if we're going up 2, that means this point where it crosses the x-axis is going to go up 2. So 1, 2. It's kind of hard to do. This one's 1, 2. And then, of course, this is going to be 1, 2. So I should actually be labeling this the difference between the two here. The other one here, the green. Get in the habit of doing that. So this is y equals log base 3 of x minus 2, x minus 1, x minus 1 base 3. Okay, so my vertical asymptote is still x equals 0. What's my x-intercept this time? It's hard to tell. Okay, so if we can't tell, you do know? No, I don't think you can tell. So how do you do it algebraically if you can't tell graphically? Solve for it. So that means I would put what to 0? The y to 0. So 0 equals log of x plus 2. Then what? Move the 2 over. Okay. So I have -2 equals log of x. Can anybody take a guess what to do next? I've never shown you how to do this, so you're taking a leap now. What does it look like that it's crossing this blue here? It's a very small number, right? Yes, that's what it is. Its x is going to be 10 to the power -2. Remember, the base is 10. If you change it to exponential, you'll actually solve what x is. You'll undo this x here if you change it into exponential. Because remember, logarithm is the inverse of exponential. So if you exponentialize a log, you are undoing the log, right? So do you see that my x-intercept is actually 1 over 100? Yes? Domain. 0 to infinity. And my range? -infinity to +infinity. Yeah?
Can you explain the x-intercept one more time?
Uh-oh. Okay, so what's happening here? Oh, my. Oh, my. Yes, does everybody see we have to factor here? So this is going to be log, I don't know why I put the 10 there, but I'm going to not write it this time. It's going to be 2 bracket x plus, what is that going to be then? 3 over 2, 1.5, right? Yes, everybody go with that? Okay, so let's graph our base log graph, which is the 10 base, right? Again, if you forget how to do that, that would be 10 to the power y equals x in order to get that. But I hope by now you realize it's always going through 1, 0, right? And then if the base is 10, that the next one, when it's a height of 1, it's going to be 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 is going to be at 1. And at 1/10, it'll be -1. So there you go. So this is y equals log of x. Okay? So who can describe, going back up here, what happened? Who can describe what happened in the transformation? What does the 2 do? Horizontal, stretch, factor, a half. What does the 3 over 2 do? Left, 1.5. I'll just write it as 1.5 so we can see that better. Are we good? We good? Okay, so that means we're going to take these 3 points and do the following. Can anybody tell me where my new asymptote is going to be? Where's my new asymptote going to be? Yeah, -3 over 2. So that would be 1.5, right? -1.5. I don't know why I did that right up there, so I'm going to erase that because we don't need it up there. Oops. I erased a little bit too much. Okay, so 10. The x value is 10. Now it's going to become 5. Oh, 1, 2, 3, 4, 5. So right there, 1, 2, 3, 4, 5. 10 gets shrunk, right? Stretched half. So it's at 5, and then it's going to go left 1.5. So 1.5 right there. Do you want me to repeat that? Okay, so then this one, a x value of 1 gets halved. So now it's at a half, right? And then it has to move left 1.5. So do you see it's going to be at that? Yes? Okay, this one might be a little harder to do because it's 1/10. How do you have 1/10? 1/20th? And then it's just really close to the, yeah. So it's going to look like that. That's why sometimes you're only going to get 2 points out of this, right? Because it's too squished or too small or too big, right? Okay. Doing pretty good. Okay, let's answer the questions there. My asymptote is x equals -3 over 2. Yes? Everybody knows you have to write it as an equation. What's my x-intercept? -1. Just for fun, let's solve this algebraically just to verify it was -1 now that we know how to do this. So 0 equals log of 2x plus 3. Does everybody see what I'm doing right now? Okay, so remember to undo a log, we exponentialize. So what is my base here? 10. So what is it going to be? 10 to the power 0? Yes. 10 to, remember the log always equals the exponent, right? So 10 to the power 0 equals 2x plus 3. What's 10 to the power 0? 1. So 1 equals 2x plus 3. Move the 3 over. I get -2 equals 2x. So x equals -1. Does everybody see I verified it was -1? Do you see how I did it this time? All right. Domain. -3 over 2 to infinity, and the range is all reals, right? Okay. Next one. You good? All right. How about this one? What happened here? We have to factor, yes. So log with a base 2, factor out the negative, what do I get? X plus 1. Verify. If I multiply that in, do I get what I started with? A lot of people forget that the negative x, that negative needs to be factored out to see it, right? Okay, what does this negative mean? Reflection over the y-axis, and what does that mean? I'm sorry? 1 left. 1 left. Okay, so we're going to do a base 2 log graph. If you forgot how to do that, that's 2 to the power y equals x for my base 2 log graph. So 1, 2, 1, 2. At 2 it's 1. At 1 it's 0. At 1/2 it's -1, right? So it's right there like that. Okay, everybody see my 3 points to switch, to move? I shouldn't say switch. Okay, so we're going to reflect over the y-axis. So let's start with the most right point here. So the most right point is 2, 1. Does everybody see that? 2, 1 becomes -2, 1, and then it's going to go left 1. Does everybody see there's my new point? Yes? Okay, so then this x-intercept of 1, 0 becomes -1, 0, then left 1, yes? Where's my new asymptote going to be? Is it going to be the same? No. It's going to be at -1, so I'm just going to put that in there just so I know. So then this x value of 1/2 becomes -1/2. It's going to be over, right? So it's going to look like, whoops, I'll try that again. Like that. That's my y equals log of -x minus 1, yeah? Okay. My new asymptote, again, was x equals -1. So we'll fill in the rest. Vertical asymptote, x equals -1. What's my new x-intercept? At -2. And again, just for fun, let's solve it. 0 equals log of -x minus 1 base 2. So how do we do this? How do we solve this? Exponentialize, right? So what do we do? 2 to the power of 0 equals -x minus 1, yes? Yes? What's 2 to the power of 0? 1 equals -x minus 1. Move the 1 over. We get 2 equals -x. Switch the signs. X is -2. See how that works? Craziness. Domain. Ooh, what's the domain this time? Yes, -infinity to -1. Remember, you have to go least to greatest. And my domain, my range is all real numbers, right? Okay, so the change of base theorem, the reason why we have the change of base theorem is because not all calculators have that nice little feature where you can change the base by just inputting one little thing. So I'm going to show you how to do it the old-fashioned way, or with a calculator that you don't have that way to do it. I think you should still try to do it and then verify it with your calculator feature. But anyways, log of n base b is equal to log of n divided by log of b. I thought I actually showed this proof somewhere, but I don't know. I guess I don't. So Just take it from my word, and I think we have to do some more log theorems before I can actually show you that proof. So this theorem can be used to change logs to a base of 10. Why would I want to change it to a base of 10? Because all calculators have the log feature with a base of 10, right? They don't have the feature that has logs with different bases. So that means we can use our calculator to evaluate it. So evaluate the following to 2 decimal places. So I want you to use the log feature of your calculator, not the change of base feature. So how would I change log of 3 base 2? That would be log 3 divided by log 2. Yes? And what do we get as the decimal answer? We just type in log 3 divided by log 2. Did you get 1.58496? Yeah. So the people that have the TI-83 that don't have that feature, this is how you'd have to do it, right? Okay. The people that have the nice change of base feature, use your calculator now with the change of base and verify that you get 1.58496. Yeah. Okay, so what would this be if I were to use the change of base theorem? Log of 782 divided by log of 5. Does everybody see what I'm doing? The base becomes the denominator and the argument becomes the numerator as part of the log. So let's try that one. .13924. Yes?
Would you lose marks for exceeding like 3 decimal places that I asked for, or is that?
Oh, I didn't even realize it said that. Actually, that's a great question. So the question was, would you lose marks if you went too many decimal places? The correct answer is, the answer is, you will not lose marks if you go more than the decimal places allotted, but you will lose marks if you go less than the decimal places allotted. And in this course, it is always correct to 3, so that's why I always go 4, and I didn't even think about that. So, yeah. Okay, so how would you do this one with the change of base theorem? Yeah, log 8 divided by log 3 plus log 7 divided by log 4. So try that. .2964. Is that what you got? Okay, very good. Okay, so now this brings us to, let's use the change of base to solve this. Now, this is not in log form, but you know how to change this to log form, don't you? How would I change 2 to the power x equals 3? How do I change 2 to the power x equals 3 into logarithm form? The exponent x equals log of 3 base 2. Okay, how would I use the change of base theorem to evaluate this? This would be log of 3 divided by log of 2. Or you can use your fancy calculator move there. We already got the answer to that one before. That's where you go to math and then toggle up to A and change the base that way. But like for normal calculators, they would not have that feature. 1.58496, blah, blah, blah. Did everybody get that? So again, unless it says you need to show the change of base, the graphing calculator TI-84 and above has an advantage. They don't have to memorize how to punch this into their calculator. They can just use the Math A feature to do this, right? So, okay, so this one is from the provincial exams. We're not using a calculator on this one. This was a question asked fairly recently. It's actually asked quite a few times. This is on the non-calculator part, and it's saying which logarithm is larger, log of 35 base 2 or log of 70 base 3. So how would you do this? You have to justify. So this is very similar to the question that we just started off, which was log of 35 base 5, right? No, but we don't have a calculator to.
For your calculator, that's saying like the log in base 10 of 35 divided by the log in base 10 of 2.
Yeah. Yeah. Okay, so does anybody know roughly what log of 35 base 2 would be? Huh? Anybody? 5 point something for sure. So since log of 35 base 2 is approximately, let's just leave 5 point something. I'll say because 2 to the power 5 is 32. The next one would be 2 to the power 6, right? Is 64. So what's the 2 point something, do you think? Sorry, 5 point something. 5.1 or 5.2. Since you're estimating, as long as you're close, right? What do you want to go with? 5.2? Okay. And what do you think log of 70 base 3 is? It's going to be what? 3 point something. Why is it 3 point something? Because 3 to the power 3 is 27, and 3 to the power 4 is 81. What do you think the 3 point something is going to be? Yeah, it's going to be closer to 81 than 27, so 3.6, 3.7? You're going to even say 3.8? It doesn't really matter. All we're trying to do is which one's bigger. So since that is that and that is that, log of 35 base 2 is bigger than log of 70 base 3. Okay, let's verify this on our calculator. Remember how to do this. If you don't have the change of base theorem, you just go log 35 divided by log 2. 5.12, so we're close. Like they're not going to take marks off if you're estimating, right? Sorry, what'd you say? Yeah, you shouldn't be. As the question was, is it incorrect to capitalize the log? You shouldn't. So this one's 3.86, so whatever, you know what I mean? We're pretty close. Okay, next one. Again, this is without a calculator. How would you evaluate log of 125 base 5, and that's log of that base 3? Yes, you need to use order of operations. You need to do the bracket first. Can anybody tell me what log of 125 base 5 is? Does everybody know it's 3? Yes. So then this is log of 3 base 3. This is one of those ones I said, if you recognize that right away, you should know the answer right away, right? But if you don't, 3 to the power what gives you 3? 1. Okay, here's another provincial exam question. These are all 1-mark questions. Find the inverse if f of x equals log of x. So how would I find the inverse? Switch the x and the y around and then resolve for the new y. So this is my y, so this becomes my x. Yes? Now I need to resolve for my y. Well, how am I going to get y unattached from that log? I need to exponentialize, right? So 10 to the power x equals y. So what's my inverse then? Inverse is 10 to the power x. And does that make sense that that would be the inverse? We should have already knew that answer, right? We didn't need to do all that. We were... Yeah, actually, that's a good note. Do you see when you inverse a log, It says 10 to the power x. Okay, what's the range of the function f of x equals 2 to the power x plus 1? Do you remember what a 2 to the power x graph looks like? Yeah. Uh-oh, uh-oh. So, what is the range of that? So, do a quick sketch if you don't remember. Remember, a 2 to the power x looks like this. So, what does the plus 1 do? It makes the asymptote go up 1. So, what do you think that's going to look like? Something like that. So, what's my range? Does it include 1? No. So, 1 to infinity is the answer. Very good. What is the domain of f of x equals log of negative x base 3? So remember, a normal log looks something like this, yes? So what's going to happen when I have a negative x there? What would that be? That would be a reflection over the y-axis. So it's going to look like that, yes? So what is my domain? What's my domain? Negative infinity to 0. Very good. When you're doing quick answers like this that's worth 1 mark and the graph doesn't give you the points, do on scrap paper your easy sketch, right?